Good morning, everyone. Hey there. Happy so many people are here. I was afraid having the first slot after the party that I would be just by myself, basically. I thought maybe I'd just not even come. But hey, it's great that so many people are here. That's awesome. So my name is Nicolai. I'm going to talk about myself later, maybe a little bit. Let's start with the actual topic. And this is weird. It said Java 9 in the schedule. But once you've moved to 9, which is kind of hard right now because it's not even easy to get JDK 9 downloads anymore, you can want to move to 10 and then 11 eventually. And we're going to do all of that today. So we're going to start with 9 and then go to 10 and 11. So this is just about running your existing application on these Java versions. It's not about building modules. That's a different thing. You don't have to do that. If you're worried about the module system, it's some things that are to worry about, but you don't have to turn your code into modules to work on 9, 10, or 11. And likely you will never have to do that in any future version. And then also, because we're today looking at the migration problems you might be facing, that also means we're only going to look at the bad stuff. Java 9 has a lot to offer, and 10 and 11 also have a little bit to offer. We're not going to look at those things. So please don't go away from this talk and think this is a lot of pain and I don't get anything for this. We're only going to focus on the pain today, but there are advantages. And I advise you to look, search online or look at other talks. People will tell you about those. The slides are online already. If you go to slides.codefx.org, you will see it on the right side if you want to follow along. And the project I'm going to demonstrate here is also online on github.com/codefx.org. Blah, blah, blah. So you can do it yourself if you want to. So I assume most of you know the Java Platform Module System, the JPMS, but I'm still going to repeat it very quickly because it is the source for most of the problems that we're going to face. This is not the official byline of Project Jigsaw, but I think it could have been a fair one. So why do we even have modules in Java 9? We didn't before, and that was fine, right? Actually, I think it wasn't really fine. We just got used to all the problems that we used to face in the past. Usually we call them jar hell, which is the problem. The underlying problem is that jars did not have a name that the JVM really cared about. We didn't have explicit dependencies. A jar depends on other jars. We know that, but the JVM doesn't know that. And a jar could not really have its own public API. Every class that is public within the entire JVM. There's no, or at least, yeah. So there's no way for a jar to say this is public within the jar, but not outside the jar. And also, there was no concept of versions. You had Guava 19 and Guava 21 on the class path, and then it's basically flip of a coin what happens. Some of these consequences were like the no class def found error when a dependency is missing, or you get no encapsulation across jars. If you have a library, then everybody was free to use all the internals that they wanted to. Even if it's not public, they could just use reflection and do it anyway. And of course, you had version conflicts. So now, enter the module system, trying to fix these problems. We get the first three things that I said that jars don't have. Modules have them. Modules have proper names that the JVM cares about and understands. They declare dependencies on other modules. And also they can define a public API. They still don't really have a concept of versions. So if you want to use the module system to solve your version conflicts, then you're out of luck. And the module system's goals change a lot over time, and there are a lot of them, and we could discuss them at length. But we're just going to focus on two very quickly: reliable configuration and store encapsulation, the most important goals of the module system. How does the module system work? You declare a file module info.java. And this is the file, how it would look for java.sql. Ignore the transitive. It says requires these other two modules. So Java SQL apparently uses Java logging and Java XML. And then it exports a couple of packages down there. We're also going to ignore the uses today. So this is a module info Java file for the Java SQL module. If you create your own module, then you would create similar files. And then you would compile it to module info class. It would end up in your jar, and then you got a modular jar. So let's look at the two things that I mentioned: reliable configuration and store encapsulation. These requires clauses that you have up, the requires directives that you have up here are important for the module system because it interprets them. When the module system starts, at launch time or at compile time, it makes sure that all the required modules are actually present. So you cannot be in a situation that your system has been running for an hour, and for the first time you use that weird, whatever, login backend, and then it crashes on you. There can be no ambiguity. You cannot have two jars claiming that they are the same module. You cannot have static dependency cycles, which some people think is too strictly a rule. And you cannot have split packages. And we're going to look at those later, what exactly that means. So basically what the module system is trying to do is trying to make sure that the configuration of jars that you want to launch your system with, that they make sense, that they are reliable, that they give the impression that they can actually run the system that you're trying to launch without, or with fewer unforeseen problems. This is of course not a perfect system, right? To see that all required modules are present, there just has to be a jar that claims to be that module. Whether it actually contains the right classes, that's the thing that the module system does not check. So it's not foolproof, but it fixes a lot of things. What I find more important is strong encapsulation. That's the second important goal. And it deals with these export directives. So let's say you, as your code, your code is in a module, and you want to use the result set from the Java SQL package. So then result set has to be public, and that's normal. If you want to go across package boundaries, the other class has to be public. That's normal. But there are two new rules. Java SQL, the package, is exported by the module that owns it, which is the case. We can see up here that the module exports the package. But, oh, that one. Java SQL, not Java SQL. And then, so the module has to say, look, everybody can use this package, and then the public types in that package become usable. At the same time, your module has to read Java SQL, which means your module usually has to say, I require Java SQL. You cannot accidentally use stuff that is all over the class path. You can only use stuff that you declare a dependency on. And I think the second rule is an important one here for everybody maintaining a library or framework or a JDK or even a large application, where you can say, look, this is the part of my code that I actually prepared to be publicly used, and I have reason to believe that all the other code is not used by anyone anymore, which is not the case before the module system. You can whatever is public, everybody would use. And now you have a way to say, like, look, these packages are really internal because I don't export them. So if you use a module system, then it will step in and not let you use them. So that was the very quick repeat of the module system, and you're not supposed to read all the details here. I just want to show you this. This is a partial module graph. So the JDK got split into lots of modules. You will see Java base down here, which contains object and class and string and all these essential classes. You see a bunch of other ones up there. For example, SQL must be somewhere. There's the Java SQL, and there's Java Desktop. And so the JDK got split up into about 30 modules that start with Java dot something, and another 70 modules that start with JDK dot something. And the official Java SE APIs are all in these Java dot something modules. So you will primarily use these. And there are tons of other features in the module system that we're not going to cover today. So I'm just going to leave you with that slide so you get an impression if you don't know the module system well. There's more hidden. Services are a nice feature. The requires and exports I just showed you, you can use them on a much finer grained level if you have to. There are mechanisms in there specifically for reflection. And what we're going to look at now, or at least later in the moment, is the unnamed module, which is important for migration, and also automatic modules. We're not going to look at those, which are important if you actually want to modularize your application step by step instead of in one go. Layers are important for containers like application servers, not so important for us. And then you have JLink. It's a really cool tool which you can create runtimes, either create just a small JDK just for your application with just the stuff you need, or you can even include your application in it, so you get one deployment unit, which is basically like a binary you can give someone, which contains your application and the JDK and requires nothing else outside of that deployment unit. Okay, that was the module system. Now let's go to my initial idea where I said we have a running application on Java 8. Now we want to make it work on Java 9. So the first question is, why does that even work? I mean, the module system is there. It's in operation. Doesn't it need everything to be a module? And the answer is yes, it does. It actually needs everything to be a module. But at the same time, for compatibility reasons, we of course want a Java 8 application that runs on the class path to still work in Java 9 on the class path. So how is that there's a tension there? How does that get resolved? And that's the solution to that is the unnamed module that I mentioned earlier. So for all the jars that are on the class path, the module system creates a single module for all of them and stuffs all of them into this unnamed module. We talked about three properties: names, dependencies, and defined API. How does the unnamed module fare? It has no name. Kind of makes sense because it's the unnamed module, and there's a reason for that. Because you cannot reference it. You cannot say, I require the unnamed module. That doesn't work. If the code is on the class path, it can read all other code, which is the second property. It declares a dependency implicitly on all the other code. But other code cannot look at the unnamed module by default. And exports all its packages. So it's really like when you talk about the three important properties of the modules, then all three of them are technically fulfilled, but in a weird and not very sensible way. But it makes sense because then you can, even though the properties themselves are not that relevant, are not that strictly enforced, like exports all packages, that's hardly strong encapsulation. But the good thing is that now the class path has its module and works within the module system. Now the rest of the operations of the module system can work with this unnamed module. And whatever crazy things you were doing on the class path, like maybe even having the same dependency twice and it works for you, or patching a jar by having some classes in a different jar that's further in front of the class path, these kind of things still work. So within the unnamed module, all that the chaos of the class path, that still lives on. Okay, and that the unnamed module is important because all we want to do now is running within the unnamed module because we're not declaring our own modules yet. So now let's think about taking our Java 8 application and putting it on Java 9. So the thing is, some of the internal changes in the JDK can break existing code. Most of that happens in a way that is strictly speaking backwards compatible because it does not change defined behavior. But at the same time, if your code breaks, it still doesn't feel great that it does, and you still have to fix it. And this can happen even if you just run on the Java 9 class path. So the problems I'm going to show you now are partially caused by the module system, but you will experience them even if you don't use the module system yourself. Okay, before we get to something, let's look at some code. So I have this demo application here, which what it does is like assume they were like a microservice network or some other kind of services network, and this one observes it. So it pings the services and tries to gather some lifeless data, and so it's very, very simplistic. Of course, like the real code doesn't do any of that. It just makes up number out of thin air. So we got a couple of Maven modules here, and we got a parent POM here. And now when we go here, we can, let's see. I'm going to be on the right. So anyway, we can Maven clean install this thing, and hopefully it builds. Oh, why is it? Wait. Should be in color. It should be Maven 3. It's not though. Maven. Oh yeah, it was just the one terminal where I screwed up there. Okay, so here we go. We built. Maven builds the whole thing on Java 8 now. We're still on Java 8. It builds the whole thing, and we can launch the application as usual with Java class path, and then I'm too lazy to type it all out. So here you go. The class path is the libraries in libs, and the thing I just built is this jar, and I just start the main method, and there we go. In the beginning, what does it do? It lists some class path content for whatever reason. Maybe some op guy wanted that. Who knows? Could be log, ideally. So we get the class path content, and then every second we get like a small block of data points for 10 seconds. And just for fun, there's also a small endpoint that exposes this data as XML. And so there you go. It changes every second. Now the program is done. Okay, so that's very simple, right? The important takeaway is we can build this on 8, we can run this on 8, and it behaves as expected. Okay, now we want to do this on 9. So the first step is actually get a JDK 9 from somewhere, install it. If you're on Windows and you use the regular installer, it will wipe your Java 8 install, and you will now use Java 9 for everything, which maybe not the best way to go, I'm not sure. So what I usually do is on Linux, I just download the tars and unpack them. And so my official Java that is installed is still Java 8. So I want to run Maven on a different Java version. And there are different ways to do this. One that I found to be basically the easiest one. In home, you have a .mavenrc file. And if you go there, you can define some environment variables, like, for example, Java Home. So I define Java Home to point to my JDK 9 install. I found that a quick way to switch between Java versions, but you can do whatever feels right for you. So now when I go Maven version, oh, by the way, I didn't ask. Anybody can read this, right? Should it be larger or smaller or a little bit larger? It's this? Okay. Let's go over here, do the same thing here. Okay, so I now asked Maven for the version, and it says not only Maven 3.05, it also mentions the Java version, which is 9.04 here, the last release, and I have the Oracle JDK running. Okay, so now we can expect to build with Java 9. If you want to do that, then it might make sense to actually set the target to Java 9 as well, so you create Java 9 bytecode if you want to. So you would go to your POM, and then somewhere here, is that the parent POM? Let me see, that's the parent POM. Somewhere in the compiler plugin, or here you would go, I want to have source and target on 8. Now, if you want a baseline against 9, you can change this to 9. But that then means that everybody's forced to use Java 9. Maybe you don't want that. So what I find, what I did during our migration, to keep the Java 8 build running while working on Java 9, I used a lot of profiles. And I copy-paste this from somewhere else, so I don't actually have to type it all here. So if you're using Maven, you should get used to profiles. If you're building for Java 9, if you're using Gradle, then I'm sure Gradle has something similar. Maybe Paul can help us later. So what I do here is I create a profile which automatically activates itself when it's running on 9 or later. This is like an open interval. If the JDK that is actually currently running this build is JDK 9 or later, then this profile will activate. And then within that profile, I can configure my build specifically for Java 9, which comes in handy a lot of times. So let's first start by actually by setting source and target to 9. The cool thing is we don't have to set source and target, because since Java 9, there is a new flag called release. So we can just set release to 9. Okay, so now when we're building on Java 9, we're actually going to create Java 9 bytecode. And we could also use Java 9 features, but that would of course break the Java 8 build, so we don't want that. And now things are unfortunately going to fall apart. So we maybe can install the thing, and that's my recommendation to you. If you want to try this, get Java 9, install it, and just start your build and see what fails. Okay, so this fails in the utils. Where's the cursor? Oh, so it fails in the utils build. Sorry, in the utils project here. And it fails because cannot find symbol base 64 encoder sunmisc package. Okay, so there are two things to discuss here. The first one is I'm using something from a sunmisc package. I'm not supposed to. I think Oracle pulled out an old Sun page from like the end of the 90s, which said never use Sun packages ever. Why? The answer is that those are internal APIs that we're not supposed to use. They are not supported. So this is the first thing that can fall apart. Everything in Sunstar and most of the things in ComSunstar, unless they're marked, are internal APIs. And as I just told you about the module system, it encapsulates those internal APIs. It does not export them. So when you compile against them, you get a compile error. For now, at runtime, that would still work. So if you have code that was compiled on Java 8 and you run it on Java 9, it can still use internal APIs. But generally speaking, all the things in sun.star are unavailable, and you should move away from them as quickly as possible. And that includes some of the APIs like sunmisc unsafe that might exist a little while longer. If you're an application developer like I am, it's unlikely that you're using sunmisc unsafe yourself. But if your application is non-trivial, you have a fairly high chance that one of your tools is using it. For example, Mockito or Netty, as far as I know. So there are a lot of projects using sunmisc unsafe. And the reason is that you can do things with it in a very performant way that you could otherwise not do on the JVM. But it's still an internal API. So now there is an effort to standardize some of its APIs, polish them, and publish them in a proper way, and reduce the need to use sunmisc unsafe over time. So these APIs, some of them might survive longer. So what can you do to find these? You can use jdeps, which is a cool new command line tool. It has flagged JDK internals, and you can use it by this way. I use it on a different project. This is my class path, and I tell it to recursively go not only through my code, but through all the code that I use, all the dependencies as well, and then it reports things like this. So here apparently Bartik codec jar, which is a dependency of this scaffold hunter, uses the removed internal API JPEG image writer. And Guava 18 uses unsafe, and the scaffold hunter itself uses the Windows combo box UI, apparently. So run this on your code, and you'll get your internal dependencies, or your dependencies on internal APIs, and your dependencies on internal APIs. But this only analyzes bytecode. So if you use reflection, you have to check that as well, manually. Any call of class for name, which usually starts these reflection pipelines, could be, is a cause for consideration to look into it. And the calls to set accessible, these are specifically the calls that might fail. If you call set accessible on something that is an internal API, it will fail. Or it will fail in the future, now you will get a warning on the command line. And the problem with that is that also applies to your dependencies. So for example, Juice up to 4.1, I think even 4.2, I'm not sure, used the class loader defined class. Actually, a lot of things use class loader defined class, which is a non-public API. They use reflection to access it. And so you get a lot of now warnings on some future Java versions, you will get errors. So what do you do when you find these? You fix your code, of course, if it's yours. If it's a dependency, you actually you should immediately look for an issue. Are they aware of that? If not, make the maintainers aware of it so they can fix it. And then maybe look for alternatives. So if you're using some internal JDK API, there's a fair chance that there's a public API that you should be using instead. If you're on a library that is not maintained anymore, maybe nobody's going to fix that. So look for an alternative library that helps you. And then there are some command line flags that you can use to export packages that are not originally exported, to open packages for reflection, or even to permit illegal access in general. But we're not going to look into those. So which one of those applies here? The interesting answer is actually none. Sunmisk base 64 encoder is deprecated since what, Java 6 or something. It's just gone. The class is really gone. I'm not supposed to use it anyway. And the replacement for that is, let's see, which class was that? That caused the problem, utils, of course. So I should not use the Sun class here. I should just. This is, what is it? Base 64, I think, right? Yeah, get encoder and then encode to string and then content get bytes. That looks about right. And then I always forget, but now I remember to remove the import. And now this should build. Let's go to utils to just build that. Sorry. There you go. So we just built this project now, just the one, to see where that works. So compilation already worked, that's nice. And now we run the tests, and now we get some warnings. Warning, an illegal reflective access operation has occurred, blah, 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 blah. Okay, so this is another access to an internal API. And as I said, at runtime on Java 9, these internal accesses are still allowed. So if the module system would already be very strict, then this would be an error. It's not yet. So you get, instead you get a warning. And the warning says, let me go up here to read it properly, there's illegal reflective access by ByteBuddy. Okay, why? And we should maybe report this, and we can use illegal access like warn to get more warnings, and we can do all kinds of things. So the one way to fix these warnings is to actually export or open that package. So in this case, because it's using reflection, we need to open it. And I'm just going to copy paste the block because it's huge. Let's go back to the parent POM and copy the profile block. Because I'm lazy, I'm always going to copy paste around all of stuff. And then we go to the utils POM, which is down here. What? That was not the utils POM. There we go. So now this is something that might happen to you as well when you start configuring your build for Java 9. Individual subprojects will need maybe a different version of a dependency, or maybe a different, like a flag to run properly. And I always edit them in a profile, because if you not add them in a profile, you would also apply them on the Java 8 build, and then the Java 8 compiler or JVM would of course complain because it doesn't know these. So what are we going to do here? We're going to tell Surefire that when it starts, we're going to configure Surefire that when it starts, it's these command line flags to the launching JVM. What we're doing here, first we're going to say, look, I know that you're giving us illegal access by default, but I actually don't want that. I want you to deny illegal access, which gives me the advantage that the build fails when some new internal access is happening that I was not aware of. And then I explicitly open the one package that causes this problem. And this package was mentioned in the error message somewhere. This is the method Java lang, and maybe it even mentions the should even mention the module containing Java lang, but I don't see it right now. You can look it up in the Java doc I'm going to show you later. So in this case, I'm going to say open the Java lang package from the Java base module to all the unnamed modules, to all the code in the class path. And with that modification, utils builds now. But this should only be your second choice, adding these command line flags. Your first choice should be to look for a proper fix, which in the case of a dependency means you should look whether there's a newer version for it. And because Raphael Winterhalter, who is maintaining ByteBuddy, is doing awesome work, it was actually kind of hard to find a Mockito version that was old enough to have this problem. So if you just lose any recent Mockito version, this will not happen anymore. Let's fix that. I'm using 2.2.1 here. If instead I use, what is it, 2.8 something is the current release. Let's use this one. Then we actually don't need this block, and that is preferable. These blocks are like, this is technical debt that you're putting in here, right? You're saying, look, I can fix this now, but this will come back to bite me later, because you're still depending on internal API that could change any time, any minor release. So only put in these blocks if you have to. First check, is there a more current version that does the thing I want? So we run the tests again. Now without the exports, we should not get any warnings anymore. There we go. Okay. So that's the first thing to be aware of, the internal APIs that you might run into. Now the second thing, Java E modules. There are these 6 modules that contain APIs that are not really Java SE. They're basically Java EE. They were present in the JDK for historic reasons because they make integration easier, but it was never really optimal, and there were some special reservations how to work with these. And now since Oracle moved Java E anyway to Eclipse, the idea was to split things clearer. And that means that these 6 modules, they contain Java E APIs, and they are deprecated for removal in Java 9, and they're not resolved by default. That means usually your code in the unnamed module can read all other code that's there, all the other JDK code that is there, but not these 6 modules. If you want to use these 6 modules, you have to add them manually. We'll see in a minute how that goes. So again, you can use jdeps if you want to. You can use jdeps on a jar that you see, and then you say summary, and then, because otherwise it lists a lot of package dependencies, but if you just have summary, it just lists the dependencies between jars and modules, or jars and other jars. In this case, it tells you that the scaffold hunter that I'm using here depends on these modules, which are all non-Java E modules. But if you would spot a Java E module in there, you would know I have to fix that. So what should you do? You can use, you should pick a third-party implementation. We're going to see that later. Or you add them explicitly with add modules. And we're going to go through that motion now to get you a little bit more used to that. And so we're going to be back here. Once again, I copy-paste the profile block, so I don't have to repeat it or write it myself. And then we were... Oh yeah, I didn't check which exact project I'm in. Of course I do know, but let's see. Oh, I didn't even show you the error. My mistake. Let's just build. We'll see now. So we fixed one project. Let's see which one trips us next. Should play a jingle. So here you go. So here, for example, it says that the Java XML bind annotation package is not visible. So now how do we find out where it comes from? This is for the symbol for the class generated. So let's take the class generated and let's go to the Java 9 Java doc, which, by the way, is this awesome search bar up there, which some people flippantly said is the best improvement in Java 9. So you can go there and have this one here. That's not the right one. Wait, let me check. This is a... Oh yeah. This is a tricky spot. I've sometimes... Let's not look for generated. Let me check my notes. So this is the tricky thing that we're going to fix later when we talk about split packages, which is up next. What we do now is we look at the XML element, which is somewhere in these error messages as well, because generated is not actually from the JDK. That's the root problem that we're facing here with the generated thing. Let's go to XML element. There you go. So if you have a type and you don't know which module it belongs to, then be aware that in Java 9 Javadoc always lists the module that something belongs to, not only the package. So here we see that we need the Java XML bind module. So we want to add that to the build. We've just been building REST. So let's go into REST and repeat the error there. And then we want to add that module that contains that missing class. So put this here for later, and then we go to the parent. And oh no, that's useless. Okay, now again we do the same thing as before. We have the profile here, and now we add the profile specific, the Java 9 specific configuration. In this case, because it's a compile error, we're going to tell the compiler plugin to apply these command line flags to the compiler. So note that Surefire and the compiler plugin had different ways to add these arguments, which is, well, it's not the nicest thing to do. But anyway, so this way we tell the compiler to add that module during when module system builds up this whole module graph. It will include that module because it is not resolved by default because it's a Java E module. All other modules are resolved by default. Java E modules are not. Okay, so here we go. Let's build this again. Now we go down to this generated error. And generated comes from a dependency. So I know the part. I use the add_generated annotation. The add_generated annotation comes from the GSR 305 jar. And the weird thing about that is that if we run clean, let's say we just run because it just compiled, we get a little. If we turn on -x, we get all the output we ever wanted. And then in here, this is the class path. And I'm not going to try to spot it. Maybe one of you does. But somewhere in here is the JSR 305. Just trust me with it. So it is on the class path. Why would the class not be found? That's really weird. And that will happen in some circumstances. This is by far the most complicated problem that you might face. And the reason for that are the split packages that I mentioned earlier. So the idea of the module system is that a package should have a unique origin. There should just be one module that contains a package. So the official rule is no module must read the same package from two different modules. But the implementation, the implementation you're going to face is stricter. If you have, as soon as you have two modules that contain the same package, whether they're exported or not, then you get an error. So two modules, and both have the same, let's say both have the company or org library package, then you get an error. Remember that Java does not have sub-packages. So company foo is not part of company, right? So there are no subfolders, sub-packages or anything. These are two different projects, so two different packages. So one module can have company and another one can have company foo, but you cannot both have company foo. If these two modules have that, then at launch time, or in this time, at compile time, very, very early on, the module system will spot that and will tell you, look, you have two modules with the same package. That's not supposed to happen. Fix it. The thing is that the unnamed module, because of the chaos of the class path that's supposed to live on in there for compatibility reasons, is not exposed to these checks because it would fail too many of them. So this check is not applied to the class path, which means, and this is a weird thing that happens then, if you on the class path have a package that is also in the platform module, that is also in a module from the JDK, then as soon as the JDK sees that package, sorry, the class loader sees that package, it goes to that specific module and says, load that class. And then that module says, I don't have generated, doesn't belong to me. It's still on the class path, but nobody's going to check the class path afterwards. So that's, as I said, it's a weird problem, and it's not going to happen very often, but it will occasionally happen with these Java E modules. Because there are a couple of examples that split packages. So, for example, there's the XML APIs project, which I heard a lot of good things about, which splits the Java XML package. Then of JBoss module split a couple of things, and that's not necessarily a bad thing. They're allowed to do that under certain circumstances, but it can still lead to problems. And then most famously maybe is JSR 305, because it was never really released. It uses Java packages, in this case JavaX annotation, even though it was never never officially part of Java SE. So I think by license it shouldn't even be allowed to do that. But hey, it does that. So the problem that we're facing now is we have a module in the JDK that owns the JavaX annotation package, and we have a jar on the class path that has some types that we still need to use somehow. And this is where patch modules comes in. Oh yeah, if you use jdeps, it will report these as well, by the way. Automatically, you don't have to do anything, it just reports these. So what can you do? If it's your artifacts, you have a ton of choices, and the best one is the first one, just rename the packages. If these things are not supposed, if this is an accident, just rename them. And otherwise, you have to merge them some way or another. But if you have full control over this, you have a lot of options. If you don't have full control over these artifacts, you just have two choices. The first one is, maybe the dependency that you're having is actually a replacement for the JDK module. It's a full implementation of the same thing. If you use that, you can use it to upgrade the JDK module. If you don't have that, and JSR 305 does not do that, then we have to use patch module. Patch module means take the content of this jar and push it into that jar, into that module, and let's just act as if it belonged into that module. So that's really like a really last resort. So let's do that next. So we have to add more here. So we just added that module. But now we also have to patch it with some other content. Let's do that. First of all, this is kind of like a cheat. If we observe the error messages more closely, we see we also need this module. But then the important part is this patch, which is utterly weird. So what I'm going to do here, I'm going to say, I patch this specific module, which contains these annotations. I'm going to patch this, and now I have to point to the jar. Where do I get the jar from? I don't know. Maybe you add it to your directories, to your repository. I didn't. I decided to cheat Maven and say, like, give me the log repository, and then I walk manually the path to this jar, which is horrible. But there you go. Now this should work. Let's see. I want to install now because we assume it works, which it won't. For some reason that I don't know, the -- release thing that I just used, because it's so much shorter than setting source and target, doesn't work together with patch module. I'm sure there's a reason for that, but I don't know it. And at this point, I just gave up and decided I just give in. Just whatever you want me to do, as long as it builds at some point, I'm fine. Okay, that built that module. Now let's build the entire thing. Oh, didn't want to take that away from you. There we go, it works. Now we want to run it, right? So we can, if I run it like this, it doesn't work because I used the Java command, and of course I just compiled with Java 9. So where's the 53? There is 53 because I'm using Java 9 bytecode. I cannot run it on Java 8. As I said, I don't have Java 9 installed by default. I made these links so I can just say Java 9 and then blah blah blah, and then it works. And then it doesn't work. This, what does it say? This weird class loader here, class loader $app class loader, cannot be cast to Java-based JavaNet UL class loader. Okay, so what's going on here? You might find other code that does that, something like this. I'm getting the class loader and I'm casting to URL class loader. There are a bunch of reasons for that. Here I'm using the simplest reason, which is I just want to have a look at the class path content. So I just can get all the URLs and then do some fancy things so I can print them to the command line or to a log file, most likely. Other reasons to do that is to append to the class path while you're running. Some applications do that. The point is, this is no longer a URL class loader. And this is also a thing that's not an incompatibility in the strict sense, because nobody ever promised it would be a URL class loader. We just knew it was, so we just did the cast anyway. So the point is, this is no URL class loader. These casts fail, and what the fix is depends on what exactly you're trying to do there. So if you want to add something to the class path, then you're out of luck, because in Java 9 the regular class loader has an immutable class path. But you can always create a new class loader, for example, a new URL class loader with a new JARs you want to run with. If you want to just look at the class path, there is a system property that you could use. So the fix in this case could be as simple as this. Let me copy paste the code. I won't bore you too much. You can ask the system property java.class.path, and then you just get, well, the class path. And in this case, because the Linux system, they're separated by a colon. So I take them apart and stream them, and then generate the same output as before. So hopefully this works now. It's unfortunate that I have to build the entire thing again. Actually, I don't have to, but it's mentally easier for me. There we go. We fixed hopefully all the things. Let's see. Still not. No class def found error. This thing. This package, javax XML bind, should feel familiar, because we had this add modules earlier. So what generally happens is when you add modules at compile time or at test time, or when you open a package at runtime, or when you export something, when you patch something, when you apply these command line flags to make your build work, you will usually also have to apply them for the application to work. Which means if you have control over the of the command line that launches the application, because it's your application, and that's great. But if you're a library developer, then adding all these flags in your build means that most of them, or at least some of them, will also have to be applied by your users, which maybe you don't want to put onto them. So again, these flags are really just last resorts. Here we don't have to add all of these, because a lot of the things that I did are just relevant at compile time, because the lot of things had to do with annotations, and the annotations do not survive until runtime. So we don't only have to add the one module. Somewhere. Just add modules. So the same arguments, the same command lines also apply to Java XML, also apply to the Java command as they apply to the Java C command. Finally. And the endpoint is up too. Woo! Great. Okay, so this worked. Let's have a look at a few other things that can go wrong. We just did this thing. Where is it? There we go. We just did this thing with the URL class loader. Other things that could go wrong: the JDK and JRE have a slightly different folder layout. So if your code rummages around in those folders for whatever reason, that's most likely going to fail. RTjar and tools jars are gone, which is only a problem for IDEs usually. The jars that were contained in the JDK are now mostly JMod files. And down there, if you have runtime image content that you're looking at, then the URLs you get back from these APIs look differently. And we already saw this when I told you the split package thing this year. This is not how it would look on Java 8. This means Java runtime, and then comes the module name. And if you were talking about a package, then there would be a package behind that. So these URLs look differently. All the APIs have, of course, been updated, but if you build them by hand, or if you parse them by hand, then you might get into problems. So you have to look for these URLs, or if you want to check whether something is wrong with the JDK or JRE folders, does your code look into them? Or then finally search for cast to URL class loader. But all these are kind of specific problems. They're not so likely that you're going to see them. And these are even less likely, maybe. There are a couple of obsolete mechanisms that were removed, and they're obsolete now. If you look at this list and think, I don't know what any of those means, then great. Then you most likely don't have a problem. But if you do, then be aware that these are gone. And there's a little bit more. I wrote a long article about that, and I also wrote a couple of blog posts about planning this update and how you use that command line options, and a tutorial on jdeps, which independently of the module system is a good way to look at. And if you're looking at the slides, then these are, of course, all clickable links. Another thing that could break code is the new version strings. You don't get one dot anymore in the beginning, which breaks log4j1, for example. So just a small thing, but still, you could come to problems there. So what's my general advice? These are the three things that are most likely going to bite you. Internal APIs and Java E modules are fairly easy to spot. Split packages is more complicated. Whenever you're in a situation where you think, why is this class not found? I'm sure it's on the class path. If the package name starts with Java or JavaX or com or com-sun or something like that, then you might be in a split package situation. But you don't get a good error message for that. For the other two, the error messages are stellar. They usually tell you exactly what the problem is and what to do about it. So what should you do? You should get your code in shape. And to prevent relapses, I recommend to build a profile or find some other way to have your code run continuously or build continuously, sorry. Let's say your baseline is still Java 8. Put up a new build that builds on Java 9 or 10 or 11 or whatever. So all your changes get continuously built on the newest Java release as well. Even if you don't use those features yet, it still helps you to make sure that once you fix something, you don't go back and make it worse. Then you have to check all your dependencies and tools. And if any are suspicious, meaning if any are doing fancy stuff, and fancy stuff is everything that an IDE does, everything that a build tool does, everything that has to do with performance, then they're all suspicious. Check them out very closely and make sure that the projects are still maintained and that you are in a situation to update to the newest release. So a lot of these problems you will not encounter if you just use the newest version once it's a Java 9 compatible versions out there. But that means you have to be able to make that jump. If you're still stuck on Spring 3 and there's no way around, like if you cannot just update to Spring 5, then you're not benefiting from the fact that Pivotal already updated Spring for Java 9. You have to make your own updates to be sure that you can jump to Java 9 compatible version. And I think that's the best way to prepare for Java 9 without touching Java 9. Just get all your dependencies up to date. And then, of course, just download Java 9 and try it. I'm going to come to that later. We have 4 minutes left. So in those 4 minutes, for questions, find me later. The last 4 minutes, let's build on Java 10. We go to Maven RC. I have Java 10 here. And as you can tell by the fact that I'm trying this within 10 minutes, see that version tells me it's Java 10 running. As you can tell by the fact that I'm trying this in the last minute, I'm not expecting a lot of complications here. In fact, there are none. The only thing that you might run into is that Java 10 has a new bytecode level. It's now 54, and Java 11 has 55. Every 6 months, you get a new bytecode level. And if you have something that operates with bytecode, then some of those libraries might say, look, I don't know this bytecode level yet. So ASM, for example, you have to update ASM maybe. Or you have to update, sometimes you use a dependency that internally uses ASM, and then you have to tell it, use the new version instead. There are test failures. How are there test failures? Can't you find class using reflection? Oh, neat! that's the Mockito update, I think. Look at that. Oh yeah, right. When I tried this yesterday, I didn't update the Mockito version. I'm sure there's a more up-to-date Mockito version now that fixes this. I'm not going to do that here now. Forgive me for that. Then there's also a Java 11 thing, and that's more important than this. On Java 11, the add modules won't work anymore because the idea was to get JE out of Java. In Java 11, these JE modules are not there anymore. You have to, all the add modules things that I showed you is just if you really want to try Java 9 or 10, but the only proper long-term solution and the only one that works on 11 is to replace the Java E modules with a third-party implementation. And if you don't know which one these are, then welcome to the club. I didn't either. But I opened a question on Stack Overflow, and this is the answer. So for every Java EE module here, you will find a dependency that you can use instead. And those should work on Java 9. For example, for JAX-B, you have to use like 230, but they all work on Java 9. And if you Google for deprecated JPMS modules Java E, then you will find this question. Or you go to the myriad links I gave you earlier. Some of them point here. So it's the only thing you would have to do for the build for Java 11. And so I think with that, you can get to this slide. So about me, usually I invite people to follow me, but I've been very lazy over the last couple of weeks, so don't follow me. I'm not doing anything anymore. Don't go to Twitter. Don't go to my blog. Definitely don't buy the book because it's boring. And if you want to throw money at me to bore you even more, you can not hire me for Java training. Great. Thank you very much. If you have questions, just come up now.